Security 101 and a little bit more. Let's begin. If you, like me, occasionally watch some TV, you may have heard of a show called Pawn Stars. My kids really enjoy watching that with me. It's about a little pawn shop in Las Vegas and all their dealings about what they buy and what they sell and what goes on. But occasionally in that show, they'll have an item that comes in. For example, I saw a painting that came in and it was made by somebody famous. And before they made an offer on buying that, they said, hey, you know what, let me call an expert in so we can authenticate that. Validate that that's the real deal. Well, in a wireless network, we are going to want to authenticate or validate individuals to make sure we know who they are before they get onto our computer networks. What's interesting is that there's more than one way to prove the identity of a person. We can use several different factors. For example, we could ask them for something that they know. What would be something that you know, for example, that allows you to get onto online banking? Well, we know our username and our password. That's great. That would be one factor. Another factor we could use is something that the user has. An example of this would be like an ATM, an automatic teller machine, where we walk up, we put in our card, and that card is, in measurable terms, something that we physically have. We also have something we know, which is a PIN, and that would be called multi-factor authentication. Something that we know, along with something that we have. Another factor that can be used is something that you are. What do you mean, Keith? Something that I am. Well, for example, if they wanted to validate who you are by taking a blood sample and comparing your DNA against the information they had for you, that would be one method. That's not too practical if you're going in and out of the building every day. But other items, things that you are would be, for example, your fingerprint, the uniqueness of your eyeball and your retina, things of those natures. So anytime we use two or more of these categories, category 1, 2, and 3, is called multi-factor authentication. So if we ask a user for 5 things that they know, what's your mother's maiden name, what was your first pet's name, what city did you grow up in, etc., if we ask them all out of this single category, it might be better security than just asking a single question. But because we're only dealing with one item, one category, that would still be single-factor authentication. And as a general rule, multi-factor authentication, although it may not be as convenient, will always be more secure than using a single factor. Now, we can also authenticate computers and devices. For example, we have a computer on the network that is going to attach. We could do authentication of that device by having something unique to that system that it provides to the network. And ideally, if we have a user like Bob at that computer, in a perfect world, we could authenticate the machine as well as authenticate Bob with separate processes for each. That way we know we have nice, clean, healthy machines that are sitting on the network that are allowed to be there. And secondly, the users who are accessing the network through those machines are also authenticated. I'd like you to imagine that you and I are sitting at a computer on the West Coast and we're connected to the internet and we're managing a router or other network device that's on the East Coast. So we're doing this via some remote application like Telnet or SSH. The problem with using plain text protocols like Telnet is that as we have this connection that goes all the way over here, anybody who's eavesdropping on any of those packets, and every service provider would have the potential opportunity to do that. If we're sending usernames and passwords and configuration across, they'd be able to eavesdrop and see all that information. So that's why we don't like to send sensitive information in plain text. What we're going to do is we're going to encrypt that data so that anybody who does eavesdrop it without the ability to decrypt it, they won't be able to see what the details of that data are. So encryption is a method of hiding the contents or scrambling the contents of the data so that any unauthorized person, when they see it, it'll just be ciphertext, just gobbledygook to them. As an example of encryption, in a wireless network, we absolutely want to use encryption because our access points, as they send out radio frequencies and our clients send out radio frequencies, those may not be contained within the walls of our building. They may leak over into the parking lot, into the next building, to the next office. And if we don't encrypt our data, anybody listening in to those radio frequencies could potentially have our information. And that's why encryption is really important, both in a wireless and a wired local area network, to keep sensitive information confidential. So if I wrote a message like this, WKLV, LV, WKH, GDWD, what does that mean? Let's say, oh, Keith, it's a bunch of letters. It's a bunch of gobbledygook. It's actually like ciphertext. It means really nothing unless you know how to unlock this data. So here's how it works. We take plain text, we take some type of key or set of keys, and then we use an algorithm, and then we crank out the ciphertext. Now, if we send this across the network, for example, from one station to another, somebody eavesdropping it who doesn't have the keys to decrypt it won't be able to make sense of it. However, let me share with you the key regarding this encryption mechanism. This is called a Caesar cipher. And all I did with each of these is I moved them 3 off of the original letter. So the original message was this. This is the data. And if you simply go 3 characters forward in the alphabet, the T becomes a W, the H is a K, the I is an L, the S is a V, etc., all the way across. Now that is a really simple example of how a key, such as the information of how we did the encryption, could be used to decrypt it. And with something called symmetrical algorithms, we use the same key on both sides. So in this simple example of the Caesar cipher, our encryption method was to move the characters 3 off of their original position, and we use that same logic to decrypt it. That is symmetrical encryption. There's another option called asymmetrical, and with asymmetrical we use a key pair. And whenever I think of a key pair, I think of Penn and Teller. There are 2 people that work very well together, but they're very different. So with an asymmetrical algorithm, we could use one key to encrypt the data and the corresponding but yet different key that would decrypt that data. Asymmetrical algorithms are more secure, but they take a lot more CPU to pull off. A very big part of managing security is managing the keys and keeping them secure. For example, let's say we have an access point and we want to use an encryption algorithm between the access point and Bob and Lois and Susan and Kevin and Karen and all the other stations that are on the wireless network. So one method that we could use potentially is called a pre-shared key. Now, pre-shared means we're going to give everybody the key beforehand. So we configure the key on the access point if it's in autonomous mode, or we could put the key up on the controller if it's a lightweight access point, and then the controller tells him what the key is. And we can also plug in that same key on the clients of Bob and all the rest. And with this pre-shared key, we could use it for a couple of things. We could use the pre-shared key as a very loose method of authentication. Hey, you can come onto the wireless network if you know what the pre-shared key is. We could also use a pre-shared key for encryption of data as we're sending it back and forth. Now, what's the problem with the pre-shared key in general? The problem with the pre-shared key, if it's the same key on everybody's machine, is that when anybody leaves or if somebody leaks out the key to an unauthorized person, we've just compromised the security of our entire wireless network. So in general, pre-shared keys in a corporate environment are not the way to go. And we will look at more creative and more effective solutions than pre-shared keys in a subsequent video. Another option is we could have a pre-shared key that is common to everybody, but then as users start to connect, each of those users and the access point in conjunction with each other could create a second key that's dynamically generated and good, for example, for just the duration of that session from the customer. And that would be more secure than just using a pre-shared key straight up. One of the early methods of attempting to secure wireless networks was to use a protocol that's acronym is WEP. It stands for Wired Equivalent Privacy. Now, it's kind of a joke because it's nowhere even close to being equivalent of a wired network because those radio frequencies are still going out. And check this out, WEP is very, very easy to break these days. So if you want more details on how fragile WEP is and why we shouldn't use it, come join me in the Backtrack/Kali Linux series, and I'll walk you through several examples that will encourage you to never use WEP. Friends, do not let friends use WEP. However, it is an example of a pre-shared key implementation where we put the key at the clients, we put the key at the access point, and then they can use that for the authentication of an individual, and we can also use it to encrypt the data. So is it better than nothing? The answer is yes, it's slightly better than nothing. So let's have some fun with this. I'd like to do a before and after shot. No authentication, also called open authentication. And then we'll take a look at it again as we add some pretty basic authentication for our wireless network. So this is without any authentication whatsoever. Let's go ahead and properly decode this. What you'll want to do in Wireshark is grab any one of these packets, right click, and say, please decode as that is the correct dissector for this information. So I got this data, I collected it by putting one of my access points in sniffer mode, sending all the traffic to my management computer, and then I filtered the heck out of it. I got rid of all the clear to sends and request to sends and a lot of the beacons so we could focus on just the basic startup process when a client wants to associate with an access point. So we'll select peak remote, click on OK, and now we have the 6 packets of interest. So we have a client. This is an Apple, the iPhone. So it's broadcasting out a probe. There's a response that comes back from an access point saying, hey, I'm an access point. And if we look at the details of that, it's also saying, hey, this is wireless LAN 30, that's the SSID, and here's a whole bunch of parameters regarding me. So the client says, that sounds pretty good. I'd like to go ahead and authenticate with you. What are you requiring today for me to go ahead and associate with you? And the response comes back, says pretty much nothing. If we're compatible and you want to come on in, that's great with me. So these are the 2 packets with open authentication. The client and the access point responding. And then the client says, great, I'd like to go ahead and associate. Here are some of my details. And the access point says, that's great, you're now associated with me. So this capture is open authentication with 6 basic frames in it. In this video, we've taken a look at authentication, which is validating the identity either of a person or a computer. We discussed multi-factor authentication. And if we want to keep data secure, either as it sits on a disk or goes through the network, we want to encrypt that traffic with some type of encryption mechanism. The big secret, besides the actual algorithms, the math that's used to encrypt data, is the keys. I hope this has been informative for you, and I'd like to thank you for viewing.